The distribution of drugs in the U.S. is from the drug manufacturing companies to a packaging house to a master distributor who either packages for distribution through small pharmacies to fill individual prescriptions or to hospitals, long-term care, and private nursing facilities. In November 2007, we opened a new project with one of our current customers to develop a special emergency medication or drug distribution system specifically for the long-term care or nursing facility portion of the pharmaceutical drug market. Our customer builds metal carts with drawers, and the plan was to keep their factory building the physical carts, and TML would design and supply the new drug distribution system with minimal change to their current cart design. Although there were existing drug dispensing systems serving this market, we never looked at or tested these competitive products. The reasons were twofold. First, it's difficult to get access to view them in operation. And second, we were designing a completely different kind of system, and we didn't want the competitive analysis to bias our thinking for reasons of both creative thinking and to avoid the potential of patent infringement. We spent the first several months brainstorming the concepts and defining the various component parts of the system. We defined the CPU and operating system and focused on the system components. Modular design was paramount in our thinking, and designing for manufacturability, quality control, and service were all parts of our early thought process. The most basic component part would be a pill box that would contain up to 10 individually wrapped pills. Then we would mount and lock each of the pill boxes into a module that holds and controls 10 pill boxes. It was decided the minimum configuration would be 4 modules or 40 pill containers on a small desktop system, and the maximum configuration would be a 4-drawer cart with a total of 360 pill containers or 36 modules. After releasing the plastic tools in April, by mid-May we started to get off-tool sample parts, and the production pieces began to come together for simple desktop testing for fit and function. The concepts are simple, proven and mature in design nature with solenoids and LED lights, and microswitches identical to those used in a computer mouse. Our interface to the metal cart drawer built by our customer's factory is a cage that holds the modules. Each drawer contains a single cage which is made up of 3 4-packs of modules, a total of 12 modules per cart drawer. These cages, once mounted, are then connected to a system interface board that talks directly to a system CPU and related custom software inside the Windows operating system environment. We outsourced the system software to a software design team that specializes in kiosk software design. Their task was to design and integrate a pharmacy system that runs on a server. Then connect the pharmacy through the internet to a CPU running Windows on the cart. TML handled all other system design and integration with project teams both here in the US and at our operations in Xiamen, China. The cart distribution system beyond the CPU is controlled by microprocessors, which total 37 for the maximum configuration of an individual cart. By August, we were debugging the product and began to put all of the final assembled pieces together. We used internet-based communication tools to remotely operate the cart through its internet connection, and we met our initial goal of a fully operational system ready for our customer to demonstrate to their senior management group and selected potential customers. One of the basic building blocks to our system is a serial bus communication channel that receives instructions from the CPU through an interface board. Each individual pillbox has a unique address which is stored in the operating system as a specific drug when entered and loaded into the cart. Arriving at this unique address required some very creative engineering effort that makes our cart and its contents unique to the installation as required by our customer. In order to be able to test at our plant, we developed a color code and module naming procedure that allowed us to test both an individual module with 10 pillboxes and a group of 4 modules or 40 pillboxes, which you'll recall is our minimum design configuration. We designed a test program that could be used both in our factory for functional testing and at our customer's factory where the final assembly and integration to the cart takes place. We can now test down to an individual pillbox address or an entire fully loaded cart containing 360 pillboxes or any subset configuration. Today we have a finished product that has met or exceeded the design goals and expectations of our customer. A container to hold the drugs, a label identification and control system from the pharmacy to the remote installation, and a touchscreen human interface. This system requires minimal training because of the intuitive nature of the Windows-based operating system and the user-friendly, self-explanatory screen prompts. After a few hours of training, the users at both the pharmacy and the installation facility will be able to use this very secure system without difficulty. Movement of refill orders to the pharmacy are fully automatic, and even controlled narcotics, which are required in some installations, can be kept inside the secure drug administration system.